Hi everyone, wish you a very happy Holi and happy Women's Day to all the strong women out there. So today we are going to solve the problem Koko eating bananas. So Koko loves to eat bananas. There are n piles of bananas. The ith pile has piles of I bananas. Okay. The guards have gone and will come back in 8 hours. Koko can decide her bananas per hour eating speed of K. Each hour she chooses some pile of bananas and eats K bananas from that pile. If the pile has less than K bananas, she eats all of them instead and will not eat any more bananas during this hour. Coco likes to eat slowly but still wants to finish eating all the bananas before the guards return. Return the minimum integer K such that she can eat all the bananas within 8 hours. Let's try to understand this problem in a better way, okay? So Coco has these piles, okay? So first pile has 3 bananas, second pile has 6, third pile has 7 and fourth pile has 11 bananas, okay? And she wants to finish eating all these bananas in within 8 hours, right? This is her time. Now the thing is she wants to choose a speed, banana eating speed, okay? That is bananas per hour, okay? She wants to choose a speed and using that speed she will eat all the bananas. Now she wants to eat slowly, okay? So what she wants to do is she wants to choose such a speed which is minimum possible, okay? So that she can eat leisurely, she can eat slowly, and also with that speed she wants to finish the bananas in this much time only, okay? Not more than 8 hours. So we have to help her find such a speed, minimum possible speed, that is going to help her finish all the bananas in within 8 hours, okay? Let's say we choose her speed, say 10 bananas per hour, okay? And let's say she finishes all the bananas in, let's say, 5 hours. Then let's say we choose her speed 7 bananas per hour. She finishes all the bananas in, let's say, 7 hours, okay? Now let's say we choose her speed 4 bananas. She finishes all the bananas in, let's say, 9 hours. Now let's choose a speed 12. She finishes all of them in, let's say, 3 hours. So we can see this one, if we choose this 4 bananas per hour speed, she's going to take more time, right? More than 8. So we can't choose this speed. She needs to increase her speed, okay? Now in these one we see that if we choose these 3 speeds, she is going to finish all the bananas within 8 hours, right? But what is the minimum possible speed? 7, right? She wants to eat slowly, right? So she's going to choose this speed, okay? So that's what our task is. Now let's one by one choose her speed, okay? Let's say we give her a speed, okay? Coco, you try eating 1 banana in each hour, okay? So let's see if she has 3 bananas. So she is going to take 3 hours to eat 3 bananas, right? Because in 1 hour she is eating 1 banana. For 6 bananas she's going to take 6 hours. For 7 she's going to take 7, and for 11 she's going to take 11 hours. Clearly it's going to take a lot more hours, right, than she should. So she can't choose this speed, she has to increase her speed. So let's try with a bigger speed, okay? 2 bananas per hour. She's going to take 1 hour to finish 2 bananas. Then she would be left with 1 more banana, right? That would take 1 more hour, isn't it? So 1 plus 1, 2 hours. She's going to take 2 hours. Now for 6 bananas she's going to take 3 hours, right? 2 bananas in each hour. For 7 she's going to take 3 hours, okay, to eat 6 bananas, and she will be left with 1 more banana, isn't it? And that would take 1 more hour, okay? Therefore she's going to take 4 hours. Now what about this? In this case she will eat 10 bananas in 5 hours, isn't it? 5 twos are 10, and she will be left with 1 more banana, isn't it? That would take one more hour. So in total she's going to take 6 hours, which is way higher than our 8, the time constant. So let's increase our speed. Okay, fine. Clearly in 3 bananas per hour speed she's going to take 1 hour for this one, 2 hours for this one, right? 3 hours for this one. How? 6 bananas she will eat in 2 hours. 1 more banana will be left. She will take 1 more hour, isn't it? So 3 hours. And for this one, she's going to eat 9 bananas in 3 hours, right? And 2 more bananas will be left. That's going to take 1 more hour. So 4 hours. Okay. Clearly higher than the time constraint, right? She has to increase her speed. 4. Let's try. she's going to finish this in time, right? In 1 hour, say 1 hour. She's going to take 2 hours. How? Four bananas in 1 hour. Two more will be left. That's going to take one more hour. Similarly, for this, she's going to take 2 hours. Four bananas in 1 hour. Three will be left. That's going to take one more hour. For this, she's going to eat eight bananas in 2 hours. Three more will be left. That would take one more hour, right? 3 hours. Okay. Now, 3 plus 2 is 5. 5 plus 2 is 7. 7 plus 1 is 8. She's taking 8 hours, right? She has, in choosing this speed, she has finished all the bananas within 8 hours, right? Now, if we choose a bigger speed, she's still going to finish them, right? She's still going to finish them. It's going to take lesser number of hours, isn't it? But she wants to eat slowly, as slowly as possible. So this is going to be the minimum possible speed for her, okay? Minimum possible speed in which she is going to finish all the bananas in this much hours. Okay, so this is going to be our answer. Clearly, if we take 5 hours, if we take 10 hours, if we take 1,000 hours, okay, she's going to finish them anyway. But what is the least speed she's going to need? This is the least speed, right? So that's the thing. Now, what did we do actually? We tried to brute force, right? We tried to brute force and check for each possible number of bananas per hour, right? Each possible k, right? We chose a range, isn't it? And we are checking all of them one by one, one by one, one by one, isn't it? Now the thing is, what is the least speed she has to take? She has to choose at least a speed of one banana per hour, right? Okay, fine. Now, what is the maximum speed she can choose? She can choose a maximum speed of this one, right? If she chooses this, it's going to finish in 1 hour. This is going to finish in 1 hour. This is going to finish in 1 hour, and this is going to finish in 1 hour, right? So this is the maximum speed, right? We don't even need to go to hundred and thousands, right? So she needs to have a speed of at least one, and she needs to have a speed of at max 11, isn't it? So is this a range? Did our answer lie in this range? Yes, it did. So can we observe something here? Are we able to recall something from this? Yes, definitely. We did the same thing yesterday, right? What is this? We are searching for an optimal solution in a range, right? By trying different values. So if we have a range, can we apply a binary search here? Definitely we can, because our range is sorted. Our range is a sequence of sorted numbers, right? 1 2 3 4 5 6 dot 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 11. So we can definitely apply a binary search here, right? What we are going to do? We are going to choose the mid, right? We are going to choose the mid. This mid is going to be our temporary banana eating speed, and we will check if in this speed is it possible to finish all the bananas in our given time h. If it is possible, then fine, we will look for a better speed, okay? Lesser speed, because she wants to eat slowly. We will look for a better speed, okay? We will look here, okay? Now if we see that no, if we choose a lesser speed, she is not able to finish in time, then we have to increase our speed again, right? We have to increase our speed. So we are doing exactly binary search, right? Now let's quickly apply our binary search here, okay, in our example. So low is going to be at least one. She needs to have a speed of at least one banana per hour, and our high is going to be this one, right? The maximum number of piles. Okay, we saw that here, right? So 11. Now what is going to be the mid? 11 plus 1, 12 by 2, that is 6. Okay, now let's try with the speed 6 bananas per hour. She's going to finish this in 1 hour. She's going to finish this in 1 hour. She's going to finish this in 2 hours. 6 bananas in 1 hour, one more banana in another hour, and this one in 2 hours, right? 6 bananas in 1 hour, 5 bananas in one more hour. Okay, fine. Now we see that she is taking 2 plus 2, 4, 5, 6 hours, right? She's finishing in time, isn't it? Okay, fine. So this can be a potential answer. Let's keep it with ourselves, okay? Let's save it. Now let's look for a better solution. Let's try reducing our speed, okay? So how are we going to do that? We are going to decrease our high. High becomes mid minus 1, that is 5, okay? So new mid is 5 plus 1, 6, that is 3. Okay, let's try with the speed 3 bananas. Okay, this one is going to be finished in 1 hour. This one is taking 2 hours. This one is going to take 3 hours, right? 6 bananas in 2 hours, one more banana in one more hour. This one is going to take how many hours? 4 hours, right? 9 bananas in 3 hours, two more bananas in one more hour, that is 4. Okay, how much is it taking? 4 plus 3, 7 plus 2, 9. Okay, clearly greater than 8, right? So this speed is not going to work. We need to increase our speed. So increase speed to how much? Mid plus 1. 4. Now what is going to be the mid? 5 plus 4, 9 by 2, that is 4. Okay, let's try with the speed 4. This one is going to be finished in 1 hour. This one will take 2 hours, right? 4 bananas in 1 hour, 2 more bananas in 1 more hour. This will also take 2 hours. This one is going to take how much? 8 bananas in 2 hours, left 3, that will take 1 more hour, that is 3 hours, right? Okay, how much time did she take? 1 2 3 4 5 6 7 8. She took 8 hours, and our speed is also lesser, right? So this is a better answer. Let's keep it with ourselves. Okay, fine. Now let's look for a better answer. How? Mid minus 1. I becomes mid minus 1. 4 plus 4, 8 by 2, that is 4. That's going to give us the same result. Okay, now let's look for a better answer by doing what? I becomes 1 less than mid, that is 3. Okay, now our low is 4, high is 3. Clearly our condition has broken, right? Low has become greater than high, so that's where we stop. And what is the answer that we have in our hand? That is 4. So we will return this. Okay, so let us quickly write the code now. Okay, so we are going to need our high. What is our high? The maximum element, the maximum number of bananas, right? So you can do a for loop and find it out. I'm going to use a one liner. Okay, okay, fine. Now what about our low? Low is going to be 1 because we need to have at least 1 banana per hour speed, right? Okay, now answer. This is going to record each potential answers, okay, whenever we find one. Now as usual, while low less than equals to high, we calculate our mid. Low plus high minus low by 2. In other words, you can say this is nothing but the k, right? We are supposed to find k, right? Okay, now if let's say eat time piles comma mid, okay, if it's less than equals to h, right, we are going to try this mid. We are going to assume this as our temporary speed, and we are going to see that if we are able to eat all the bananas within h hours, right? So this will return us the number of hours we took if we chose this speed. If it is less than equals to h, if it is within our time constraint, then this is a possible answer, right? So let us record that, and let's look for a better answer. Okay, we decrease our search space, fine. Otherwise, if our speed fell short, we need to increase our time. Mid plus 1, and at the end, after our while loop broke, we had our answer recorded, right? So let's return answer. Okay, fine. Now let's write the eat time method. Let's take long, okay, just for safety purpose. Int piles and int, what is it? Let's call it bananas per hour. Okay, you can name it anything, speed or whatever. Long time equals to 0 for int p in piles. For each pile in piles, time is going to be plus equals to the ceiling of what? Piles by bananas per hour. Now what did we do actually? Let's see. Say we had this number of bananas and our speed is 3. Okay, so if we divide 4 by 3, that's how we calculated, right? We divided this by 3, right? Our speed. Okay, so if we divide 4 by 3, what do we get? We get 1, right? But we have one more banana left, right? What is this one? This one is nothing but the time to eat 3 bananas out of 4. This took us 1 hour, but we are still left with 1 banana, right? So that's going to take 1 more hour, right? So we are taking the ceiling of what? Ceiling of 4 by 3. 4 by 3 gives us 1.33. Now what is the ceiling of 1.33? It is 2, right? Exactly. We are going to take 2 hours, right? 1 and 1. So in order to do that, we are first going to convert it to a double, right? Otherwise, this is nothing but integer division. We need to do a double division, okay? Then only we are going to get 1.33. Then we are going to convert it to its ceiling. Otherwise, if we don't convert it to double, what is going to happen? 4 by 3, that's directly going to give us a 1. Now the ceiling of 1 is 1 only, right? So that's not going to help us. That's going to give us a wrong answer. So we are going to convert it to double, then take its ceiling, and mat.ceil returns a double value. So we convert it back to int. Typecasting, right? So that's what it does. This is pretty common sense, right? At the end, return long. Sorry, return time. We took long because we are adding all these values, right? So for safety purpose, let us take long. Okay. So this is going to be our code. Pretty simple, right? Just like yesterday. Binary searching on our potential answers. Now let's run it. Okay, let's submit. Cool. Now, what is the time complexity? Let's see. The time complexity is, first of all, this is going to be a big O of n, right? If we do a for loop also, it's going to take a big O of n. Okay, big O of n. Then what? We are performing a binary search on a range. What is this range? That range is 1 to max of piles, right? The maximum in piles. Okay, so let's consider it m. Okay, so we are performing a binary search, so big O of log m or log max, you can say. No problem. Okay, big O of log m, log max. Now in each step we are calling this method, right, which is going to take another big O of n because we are iterating over piles, that is into n. So our time complexity is finally big O of n plus n log max, right, which is nothing but n log max only. We will consider the most dominant part. So our time complexity is big O of n log max, and our space complexity is constant because we are not using any extra space. Okay, so this is pretty much our solution, right? Very similar problem, just like yesterday. There exists a lot of problems with the same kind of approach. Okay, so if you have any kind of doubt, you can put that up in the comment section. And other than that, if you like this video, do hit the like button, share this video, and subscribe to my channel, and I will see you in the next video. Bye bye.